Okay. So far what we have discussed is the management of buffers or buffer cache and the management of blocks on the disk. That is, how do you find out that which disk is free, how do you find out which disk contains the data. Okay. And to access different parts of a data which are stored on the disk, we make use of what is called an index node or inode. So for every file in the directory, we have to have an inode. Similarly, for every directory, you also have to have an inode. Now, the basic thing that is stored on the disk on which the processes operate, that is what is called a file. So you can say that file is the central element of most of the applications. That is, while processing, while execution of any program, you will access data which are stored on a file on the file system. Similarly, whenever you want to store some data, you create a file and store the data in that file. Now, these files can be organized in different forms, or the data in the file can be organized in different forms. So whenever we talk about a file or file management, there are four other terms which becomes important. The first term is called a field. Then we have what is called records. After records, we have what is our topic of discussion, that is file. Then we have database. So these are the four topics which are related to this file system. Now, what is a field? You can say that the field is the basic element of data. Say, for example, in a particular file, if we want to store the student's records. Okay, so for example, what is the roll number of a student, what is the name of the student, what is his address, in which hall he is residing, what are the subjects he has opted in a particular semester, what is his CGPA, or the grades that he has got in different subjects. So all these things can be stored in the student database. So each of these entities, say for example, roll number of the student or name of the student, each of these entities will be called a field. Okay. So it is quite well known that such a record can be maintained in the form of a table. So like this. I can form a table. The table will store various entries. So first column in the table may be the roll number. The second column in the table may be name. Third column may be the hall of residence. Fourth column may be the CGPA that the student has got. So like this it can continue. So each of these columns or each of these entities is called a field. Okay. So for example, for a student whose roll number may be say 9919201, something like this. The name may be say Thomas. Hall of residence may be say Nehru Hall. CGPA may be say 8.76. Okay. So each of them are the values which are contained in this field. Okay. So each of the columns will be called a field, and the value is an instance of the field. Similarly, a collection of all these fields, that means a collection of related fields, is called a record. So as in this case, each of these rows in the table is nothing but a record. Okay. So when you take a collection or a set of related fields, then that becomes a record. And file is nothing but a collection of similar records. So if I have a number of such entries in the table, okay, then all these entries taken together becomes a file. Right? So whenever we store a file, this file can be stored in various forms. Say for example, if I have a regular format like this, and I want to store this file, then for each of these entries, I need not specify what is the corresponding field. When I store this, I need not specify, say, roll number 9919201, name Thomas, hall of residence Nehru Hall, CGP 8.76. These details need not be put. I can simply put 9919201, followed by Thomas, followed by Nehru Hall, followed by 8.76, because this file has a regular structure. But there are situations in which case the files will not have regular structure. In such cases, we have to put the field, this is also called attribute in terms of DBMS, database management. So this will be called a field attribute, and this is the value of the attribute. So if the file does not have a regular structure, in that case, we have to store them in the form of attribute name and attribute value pair. Okay. So in such cases, instead of simply putting the values in sequence, the sequence in which they will appear, I have to store it in the form, say, roll number, then 9919201. It will be an ordered pair like this. The next entry in the file will be name Thomas. So if the file is not of regular structure, then it is needed, because otherwise I don't know that this value is the value of which attribute or which field. But if I have a regular structure like this, in that case I need not put the attribute names. I can simply store the attribute values in the sequence in which they will appear. Okay. So following this, you can also say that these records are again units of data for some application. For example, a process may read an entire record from the file just like this. So first component that it will read is maybe an integer number. Second component it will read maybe a string of characters. Third component again a string of characters. Fourth component is a floating number, and like this. Okay. So if I have such 4 entries, let us consider only these 4 entries. So if I read the contents using the same, say, fscanf function, fscanf, then my formats will be, for the first one I'll have %d integer, for the second one I'll have %s, third one I have %s, fourth one I have %f. Okay, so using such data formats, I read all these 4 components using the same read statement. So in such cases, you find that this record becomes a data entity, a data unit for that particular application. In some other applications, maybe you will be interested in only fields. Okay, so I can also read field by field, but these fields cannot be broken further. Okay, unless I have a field which is a set of characters, like this string of characters, and after reading it, I want to access each and every individual of that character string. That is of course possible by using through programming, but in general that is not needed. So fields are the data units, records are collection of related fields, and then file is a collection of similar records which are stored on the secondary storage. Okay. Then when it comes to database, a database is nothing but collection of related data. So if any of you have done any course on database management, you will find that there is a concept called relational database. Okay? And the relational database is nothing but a collection of such tables. Why? Because this table can also be considered as a relation. This is nothing but a relation. Okay. Because how do you formally define a relation? If I have, say, 2 sets A and B, okay, and I want to define that what is the relation, a binary relation between the elements of sets A and B. A binary relation between sets A and B will be simply R as a subset of A Cartesian product with B. Okay, and this can be expanded. If I want to find out relations among 4 sets, say A, B, C, and D, then relation over these 4 sets will be a subset of the Cartesian products of A, B, C, and D. And you find that in this table, whatever data we have put, that is nothing but a subset of that Cartesian product. Okay, so this table itself is a relation. So in case of relational database, all the relations are put in this form. Okay, so you can also say that a database is nothing but collection of related data. Okay, or the relation is specified with the help of relations like this. Now, what is the difference between an ordinary file system and a database system? In case of database system, the database is so designed that it can be used by a number of different applications. Okay, so for example, if I design a relational database system, then the relations should be such, or the programs to manipulate those data should be such, that given a set of data, okay, I can access that data from any application which conforms to that. So for example here, if I change the positions of these two columns, say roll number and name, first I can put name, next I can put roll number. Okay. If I write a simple application program, then the application program has to take care of this replacement of the columns or replacement of the attributes. But in case of database, it should not be so. If you simply specify that it is the roll number field that I am interested in, wherever this column roll number appears in this table, it should be able to access that. Okay. Similarly, if you are interested in the name field, then wherever in this table this name appears, it should be able to access the name field. But in case of ordinary applications that we write, in that case I have to know that how these columns are actually organized. I have to know that the first entry is roll number. If I change it, then the application program has to know that the second entry, the first entry is name and the second entry is roll number. Okay, so that is the basic difference between a database system and a file management system. Though database is nothing but some sort of file management. Okay, then how do you formally define a file management system? A file management system is nothing but a set of softwares, or specifically a set of system softwares, which is responsible for providing services to the users as far as access of file is concerned. Okay. So it will be simply a set of system softwares, so that whenever some user or some application wants to make use of the files, the system software should be able to give access to that file. Whatever be the structure of the file, whatever be the structure of the architecture of the file, the device. Okay. So whenever an user writes a program, the user need not know or need not be concerned about how the data is actually stored on the disk, okay, or what is the actual architecture of the disk, capacity of the disk, the format of the disk. All these things should not be known to the user, because in that case writing a program will be very, very difficult. So whenever I want to open a file, I simply say use some command like fopen with the file name. That's all. Okay. I need not know that what is the hardware involved, or what is the driver, whether the data transfer will be done using some interrupt or using some DMA or using some poll IO, whatever it is. The user need not be worried for that. That has to be taken care of by the system software and the associated drivers and the controllers. Okay. So giving an access to the user to any file whenever needed, that is the major responsibility of the file management system. So a file management system must meet various requirements. So obviously the first requirement will be the storage, retrieval, and manipulation of the data. So all the software, systems level softwares which are involved in the file management system, they must give these facilities to the user of the application. That means the application should be able to store the data on the file system. The user should be able to retrieve the data from the file system. The user should also be able to manipulate the data on the file system. Okay. Then the second need is validity of the data. The file management system should guarantee to the extent possible that the data contained in the file is valid. That is also a responsibility of the file management system. Then the third responsibility is to optimize performance. When I say optimization of performance, I can have two kinds of optimization. The first kind of optimization is related to the user, a person who is working on a terminal, and the second kind of optimization is related to the system. So far as system is concerned, the performance optimization means the overall throughput of the system should be maximized. Okay? Whereas, when the user is concerned, optimization of the performance means the response time should be minimum. Okay? So I have two different optimization criteria. One is to increase or maximize the throughput, and in the other case, it has to be minimization of the response time. Then next, what it has to support is, on a system I can have different types of devices or different types of file systems. Okay? So this file management system should be able to support a variety of devices. Okay? So it should give support to varieties of devices. Okay. Then next responsibility of the file management system will be there should be a set of standard system calls. So for example, if I today on one system and I use some system calls for accessing the files, and tomorrow if I work on some other systems, I find that the system calls are totally different. Okay, so that puts a lot of trouble on part of the programmer or the user. So there should be a standard set of I/O routines. Or I/O interface routines. Okay. The next responsibility should be, if the system is a multi-user system, then simultaneously a number of different applications or the number of different users will try to access the file system simultaneously. Okay. So it should also support simultaneous access of the files on the file system by more than one user simultaneously. Okay. So I have to have a multi-user support. So these are the different responsibilities of the file management system or the softwares which are involved in the file system. Now, in order to ensure all these operations, a file system has a specific architecture, so which is known as a file system architecture. So a file system architecture can be put like this. On one end of this file system architecture, we have the user processes or the application softwares, and at the other end, we have the file system, that is the physical file system. In between, we have to have all the softwares which must give access to the access of the physical file system to the user who is requesting it. Okay, so in order to achieve all these tasks, the file systems are organized like this. It has different layers of functions. Of course, our ultimate goal is to give access to the user programs. Okay, and on the other end, we have the devices. Okay, so naturally, whenever the device has to be accessed, then I have to have a set of softwares which are known as device drivers. So it is the responsibility of the device driver is to have an interface with the physical devices. And naturally, since we can have different devices of different characteristics, so for example, the disk is a block device that we have said, whereas a printer is a character device. Now, depending upon what type of device you have, I have to have different device drivers. Okay? To access the disk, I'll have disk device driver. To access a printer, I have to have a printer device driver. Similarly, to access some other networking equipment, I have to have a corresponding driver. So the drivers will be different for different devices. Okay? Above the drivers, the layer that we have, that is called a basic file system. Okay? So this basic file system is the primary interface between the computer system and the environment outside the computer system. Because as I said, though these device drivers are part of the software, but for different devices, I have to have different device drivers. That means these two layers can be considered together. Okay, but I put it in this way because these are nothing but softwares. Right? And this basic file system is responsible for the interface, and whatever I have above this, that is part of the computer system. Okay. So this is the basic interface between the computer system and the environment outside the computer. Right? And what are the responsibilities of the basic file system? The basic file system, say for example, in case of a block data, it deals with blocks of data. Okay, and it does not understand what is the content of that block is. So for getting a block of data from the device and placing it within a cache, buffer cache, that will be the responsibility of the basic file system. Okay. Similarly, whenever we want to write a data on a block on the device, okay, that will also be a responsibility of the basic file system. Okay. However, the basic file system does not understand what is the content of that file. It simply takes a block, put it into buffer, simply takes a block from the buffer, puts it on the disk block. That's all. Okay. On top of this basic file system, what we have is called a basic I/O supervisor. Okay. So it is the basic I/O supervisor which is okay. The other responsibility of this device drivers routines will be to start an I/O operation, when to start reading the content of a particular block, and to process the I/O completion. That means whenever the I/O has been completed. So, for example, we want to read a particular block from the disk, so it has to start reading the block from the disk. Okay. Similarly, when the disk has been read, a particular block from the disk has been read, that will be placed on the buffer by this basic file system. But it is the device driver which is responsible for sending an interrupt or something to the CPU, indicating that that particular I/O operation is complete. Okay. The responsibility of this basic I/O supervisor unit is to monitor all these operations. Okay. So while doing so, what it has to do is, the basic I/O supervisor has to find out the device on which the I/O operation has to be done. So for example, there may be a number of devices, C, D, E, and so on which device the I/O operation has to be done. That has to be determined by the basic I/O supervisor. Okay. Not only that, the basic I/O supervisor is also responsible for buffer assignment. So as we have seen that in case of a gate block algorithm, the algorithms that we have discussed previously, there what we do is buffer assignment. So whenever a particular block is requested for, firstly the kernel has to check in the buffer cache whether the block is present or not. If the block is not present, then the kernel has to get a buffer for that block. Okay. So which buffer will be taken for loading the new block from the disk, that is the responsibility of the basic I/O supervisor. And the basic algorithms for that we have already done. Okay. Similarly, the other responsibility of the basic I/O supervisor is to performance optimization. There may be requests from the users in an arbitrary order. Okay. But the basic I/O supervisor will reschedule all those requests so that the performance of the file system is optimized. Just to give you a feel that what kind of performance optimization can be done or what kind of rescheduling can be done, let us take two examples. Okay. The first example, let us take with the help of a magnetic tape. As we have discussed before, that the magnetic tape is a serial storage device. That means it stores the records or it stores the blocks in the serial form. Okay. So suppose on a magnetic tape, I have a number of records or I have a number of blocks. So the tape continues. Okay. So the records may be something like this. So here I have record number 50. Here I can have record number say 55. Here I can have, record number 51, 52, 53. So like this it will continue. Somewhere here I'll have 70, 71, say 100, like this. These are the records. Now if different user programs or different applications puts the request like this, that some application has put a request for read of record number 100. Then there is another application who has put a request for reading of, say, record number 105. Another application has put the read operation on record number 70. Another application has put read on record number, say, 90. There is another application which has put read for record number 45, then, say, 41, then, say, 50, so like this. And this is the order sequence in which all these requests have come. So here you find if the requests are to be met in this given order, in that case, initially our read-write head will be somewhere here. This is the read-write head. Then if I want to meet the requests in this given order, the first request is for access of record number 100. That means the entire tape has to be rewinded or it has to be moved when this read-write head will come over record number 100, and then only record number 100 can be accessed. Next time record number 105, I don't have any problem because I am following the same direction. I can come to record number 105 and access it. Next request is for record number 70. So here what I have to do is I have to rewind the tape until I come to this record number 70, then only I can access it. After that I have to come to say record number 90, again in the forward direction, so I have no problem. Next record is for record number 45. So again, I have to rewind the tape. The read-write head has to come over record number 45, then only record number 45 can be accessed. Then record number 41, and then record number 50. So here you find that a number of times you have to rewind the tape, and which is just a wasted time. During that time, you cannot do any operation. Whereas, if I reschedule all these requests in ascending order of record number, okay? So I'll do it like this. First, I'll serve request for access of record number 41. Then I'll serve request for record number 45, then 50, then 70, then 90, then 100, followed by 105. So if I simply reschedule these requests in this order, the amount of time taken to read all the requests to meet all the requests will be minimal. Because now I don't have to rewind the tape unnecessarily. Simply on one go, as I move from, say, record number somewhere here, 41, to record number 105 somewhere here, on this single go, I can access all these records. I don't have to rewind the tape unnecessarily. Okay, so such a type of rescheduling is also the responsibility of this IO supervisor. Right? So this is a very, very simple case. To give you a bit more complicated situation where the rescheduling is to be done. So this can be done at regular intervals. Okay, you collect the requests over a certain period of time, and then you try to sub all those requests. Because the situation has to work in a dynamic situation. It has to work in a dynamic situation. Okay, so to give you a slightly more complicated example, suppose I have a magnetic drum. I think magnetic drum we had discussed. Okay, so it is just like a cylinder where on the cylindrical surface we have a number of tracks which stores the data. Okay, in case of a disk, it is like a plate, or on the plate we have concentric circles which stores the data, or concentric tracks. In this case, it is the cylindrical surface on which we have a number of tracks. So these are not not concentric in the sense all of them have the same radius, placed one above the other. Okay, and these tracks store the data. And in this case, the read-write head, I can have multiple read-write head situation, I can have a single read-write head situation. So suppose I have got 3 tracks, say track number 0, track number 1, and track number 2. In some cases, if I have multiple number of read-write heads, it is possible that for every track I have a read-write head. Okay? In another situation, I can have a single read-write head where the read-write head can move along the tracks. It can move from one track to another. Okay? On these tracks, data are placed in the form of blocks. So like this. So suppose this is the situation. This is block number 0, block number 1, block number 2, block number 3, block number 4, 5, 6, and 7. And suppose the disk rotates in the clockwise direction, or a drum rotates in the clockwise direction. So this is the direction of rotation. Now whenever I want to access a particular block of data on this magnetic drum, that block of data will have 2 addresses, the track number and block number. Okay? So track number 0, block number 0 indicates that this is the data block that has to be accessed. Track number 1, block number 2 indicates this block. Similarly, track number 2, block number 7 will indicate a block which is just on the other side. 7 corresponds to this one. So on this side, on track number 2, the block will have the address 27. Track number 2, block number 7. Okay. Now in this kind of situation, if I have a set of requests like this, say the requests come for track number and block number and the sequence of requests are, say, track number 0, block number 2, that is the first request, followed by track number 1, block number 2, followed by, say, track number 1, block number 3, then track number 1, block number 5, then maybe track number 2, block number 4, followed by the request track number 2, block number 3. Okay. We also assume that this magnetic drum completes one rotation in, suppose, 8 milliseconds. Okay. So 8 milliseconds for one revolution. Okay. Similarly, this read-write head can also move from one track to the adjacent track in 8 milliseconds. 8 milliseconds for read-write head movement from one track to adjacent track. Okay. So this is the disk. This is the drum specification. The drum can complete one revolution in 8 millisecond time. Also, the read-write head can move from, say, one track to the next track or adjacent track in 8 milliseconds time. And this is the sequence in which the requests have come. Then what is the optimal order? Whether this sequence is optimal, that is, if the requests are met in this given sequence, whether the time taken will be minimum, or by rescheduling these requests, I'll get a minimum time. Okay, so this is a slightly more complicated problem, and the situation will be even further complicated if we go for disk scheduling. Because in that case, I have three components. I have to have cylinder number, head number, and sector number or block number. So coming to this situation, how this scheduling can be done? I mean, just to tell you that what does this scheduling actually mean? I have to reorder these schedules. Firstly, I have to see that if I meet these requests in this given order, whether the time will be optimum, or there is any other order, any other schedule in which the requests can be made, which will minimize the time. So how to do it? See, what I can do is, I can simply redraw these tracks. So simply like this. So what I can do is, if I cut this cylindrical surface along this at the boundary of block number 0 and block number 7 and just make it flat, then I have a rectangular area of this form. This is for track number 0, track number 1, track number 2. This is block number 0, block number 1, block number 2, 3, 4, 5, 6, and 7. Okay, so what I have done is, so logically I have cut this cylindrical surface at the boundary of block number 0 and block number 7 and just made it a flat surface. Okay. Since this drum rotates in the clockwise direction, okay, so in this cylindrical surface, it will appear like this, that the read-write head will move from track number 0 to track number 7, okay, because as this drum moves in the clockwise direction, how does the read-write head traverses the blocks? First, it accesses block number 0, then block number 1, then block number 2, then block number 3, then block number 4, 5, 6, 7, then again to 0. Okay, so here, following the same concept, here it will first traverse block number 0, then block number 1, 2, 3, 4, 5, 6, 7. Then after 7, again it has to come back to block number 0. Okay, so if I simply keep this movement in mind, this flat surface is equivalent to this cylindrical surface that I have. Right? Now see how this rescheduling can be done. Let us assume that first we will schedule this 0, 2, track number 0, block number 2. Okay, however, even this can be optimized if you have a knowledge of what is the current position of the read-write head. But assuming I don't have any knowledge of the current position of the read-write head, and the first one that I want to solve is track number 0, block number 2. Okay, so the first one that I will solve is track number 0 and block number 2. So this is the one that has to be read, accessed. So once you access this entire block on track number 0, block number 2, your read-write head position is here. The next access has to be on track number 2. Okay, so at this point what I do is I initiate moving the read-write head from track number 0 to track number 1. And I know that to move the read-write head from one track to the adjacent track, it takes 8 milliseconds. Okay, so at the end of 8 milliseconds, the disk is also taking 8 milliseconds for one complete revolution. That means at the end of 8 milliseconds, the position of read-write head will be here. Okay, the next request is track number 1, block number 2. That is for reading the same one, this particular block. My current read-write head position is this. If I want to read this one, then what I have to do is the read-write head has to move over all these blocks, come back to block number 0, pass block number 0, block number 1, then block number 2. Okay, so you find that out of this entire head movement, out of this entire time, 7/8 of time is wasted. I am not using that much time, though the drum is rotating continuously, but that much time is not used for any access of block. Okay, whereas right now I know my read-write head position is here. Immediate next block which is accessible is block number 3, and I have a request for 1, 3. So why don't I do this thing? First you read 0, 2, then read 1, 3. After reading 1, 3, the next read operation is block number 1, 5. So I can read 1, 5 because it is coming in the sequence. I don't waste any time. After 1, 5, then you come to block number 1, 2. Okay. After 1, 2 is read, again the next request is from track number 2. So I have to start moving the read-write head from track number 1 to track number 2. Again it will take 8 milliseconds time. At the end of 8 milliseconds, read-write head will be placed here. Okay. So the next request is for block number 2, 4. Okay. I know my read-write head is here. I have a request for block number 2, 3. So 2, 3 is immediately available. So first you read block number 2, 3. Then you read block number 2, 4. Okay. So the sequence will be like this. First you read, so this is the first read operation, 0, 2, followed by 2, 1, 3, followed by 1, 5, followed by 1, 2, followed by 2, 3, which is followed by 2, 4. Okay. So this will be the reschedule. Firstly, I will read block number 0, 2 as given in the sequence. Next read will be for block number 1, 3. Then for 1, 5. Then for 1, 2. Then for 2, 3. Followed by 2, 4. So you find that if I schedule the requests in this order, the time taken will be minimum, and that you can verify. Given these figures, if you meet the requests in this order, what will be the total time taken? And if you meet the requests in this order, what will be the total time taken? You will find that the time taken in this order is much less compared to the time taken in this order. Okay? So such a scheduling is also the responsibility of the basic IO supervisor module. Okay? We'll talk about the other system modules in the next class.